Good morning, class 10. Let's start today's class. So, in the chapter in physics, in chapter 8, electric current. So far, we completed electric current potential difference, and then after that, the relationship between the resistance and the resistivity, the factors affecting the resistance. Today, we'll be doing numerical based on all these topics. So, first, we'll note down the formula to be used here. So, formulae used. So, from electric current, we have the formula. From electric current, we have the formula I is equal to Q upon T, which is equal to NE by T. This is the first formula. Second formula from the potential difference. Potential difference. We have the formula V is equal to W upon Q. And then again, number third, from Ohm's law, we have the formula V is equal to IR or R is equal to V by I. Then the next, number 4, that is the relationship between capital R rho L A. There is capital R is equal to how much? Rho L upon A. So this formula we are going to use here, and again we need to remember here that the number of the charge associated with each of the electron is 1.6 into 10 power minus 19 coulomb. Okay. The SI unit of resistance is ohm. The SI unit of electric current is ampere. The SI unit of potential difference is volt. So all these SI unit you need to remember. Okay, because just looking at the the SI unit given along with the value, you can confirm that which particular quantity is given, whether it is potential difference, whether it is electric current. When ampere is given, then some 10 ampere, then it must be current. If it is given that 1 volt, then it must be potential difference. If it is given 3 ohm, then it must be resistance, like that. Now, let's start with question number 1, page number 187. Page number 187, question number 1. Question number 1. Page number 187, question number 1. Now here in question number 1, it is given that in a conductor 6.25 into 10 power 16 electrons go from its end A to B in 2 seconds. Find the current flowing through the conductor, and then the charge associated with each of the electrons is given equal to 1.6 into 10 power minus 19 coulomb. Now what we'll do is that whatever the value which is given, we'll just note down. So we have number of electrons is equal to how much? 6.25 into 10 power 16 electrons, and then charge associated with each of the electron is 1.6 into 10 power minus 19 coulomb. Okay, and then again the time is also given, which is equal to how much? 2 seconds. We need to find electric current. So we know electric current, that is I is equal to how much? NE upon T. So which is equal to the value of NE is 6.25 into 10 power 16. Okay, then again the charge associated with each of the electron is 1.6 into 10 power minus 19, and whole divided by the value of time is 2 seconds, so I'll write here 2. Then now how to simplify? Here number and number will multiply, and power will multiply. So 6.25 into 1.6 is coming to how much? 6 5 30 0 3 carry, 6 to the 12 12 plus 2 15 5 1 carry, 6 36 37 into 5 to 6, so it's coming to 0, 0, 0, 1 carry 10. So after decimal, 2 number here down, after decimal, 1 number, so total 3 number will be 2 down, so it's coming to how much? 10. So 10 into 10 power is 16 minus 19, alright, divided by 2. 2 goes 10 power 5 times, so it's coming equal to 5 into 10 power how much? 16 minus 19 is coming equal to minus 3, and the SI unit of electric current is amperes, or that A, capital A. Or we can also express in milliliter form, that is 5 milliliter ampere. Okay, 10 power minus 3 means it is divided by 1000. 5 divided by 1000 ampere means it is 5 milliampere. So thus now we have done question number 1. Then let's go for the next, that is, let me go for question number 4. Question number 4. Question number 4. Question number 4. Now here in question number 4, it is given that in an electric bulb draws 1.2 ampere. Draws 1.2 ampere. Ampere is the SI unit of current, so current is equal to 1.2 ampere. And then again at how much? At 6.0 volt. So that means volt means it is potential difference which is given, that is 6 volt. Then again next, find the resistance of the filament of bulb while blowing. So we need to find the resistance. So when the potential difference and the current is given, the resistance is given by, so from Ohm's law we have, from Ohm's law we know that capital R is equal to how much? V upon I. So which is equal to V is how much? 6 upon 1.2, which is equal to 6. Remove the decimal from the numerator. After decimal, one number is here, so 1 with single 0 is multiplied to the numerator, so down 12. So 6 goes 12 for 2 times, 2 goes 10 for 5 times, so it's coming equal to how much? 5. And what is the SI unit of resistance? Ohm. Okay. So question number 5 done. Now next comes question number let me do question number 6. Question number 6. Now in question number 6 it is given that calculate the current flowing through a wire of resistance 5 ohm. So resistance is given equal to how much? 5 ohm. And then again next, the potential difference is given equal to how much? 3 volt. Okay. And then after that we are asked to find the current flowing through the wire. So that means we need to find the current. Okay, so from Ohm's law we know, that is according to Ohm's law. Ohm's law we know that I is equal to how much? V by R. Okay. So which is equal to, the value of V is 3 and the value of R is 5. So divide this coming equal to how much? Point. So 30 means 5 6 are 30. So answer is coming how much? 0.6 ampere. Then let us go for the next question number 8. Question number 8. Question number 8. Now in question number 8, it is asked that two wires of the same material. Same material means same resistivity and same length, having radii 1 mm, that is 1 millimeter and 2 millimeter respectively. Compare their resistances, their specific resistance. Okay, their specific resistance. So we know that, okay, two wires are there. So let us suppose the resistance of the first wire, as they have the same material, so rho will be same in both the cases. Rho will be same in both the cases. And then again, as length is also same, so length will be same, only the area of cross section will be different. So that is why I am denoting here A1, there A2. Okay. Now it is given that R1 is equal to the radius of the cross section is given equal to 1 mm. 1 mm means 1 by 10 centimeter. Let it be in mm only. Then again here R2 is how much? 2 mm. Okay. Now area cross section, the wire usually have circular cross section, so that is why area cross section will be pi r square. So that is why I can write here R1 is equal to pi R1 square, and then here R2 will be equal to how much? Rho L by pi R2 square. Okay, now we need to find the ratio, compare the resistance, their resistance number 1. So when we compare the resistances, then it will be how much? Rho L by pi R1 square is to rho L by pi R2 square. This rho and rho I can cancel, N and L can cancel, pi and pi can be cancelled. So it's coming how much? 1 by R1 square is to 1 by R2 square. Okay. Then again we have to express in simple fraction, simple ratio. So this goes to multiply here, this goes to multiply here. So R2 square is to R1 square. Now put the value of R2 is how much? It is 2 mm. So 2 square is 2, and R1 is how much? 1. So 1 square. So it's coming equal to 4 is to 1. So we got the ratio of resistance of the two wire as 4 is to 1. Okay, 4 is to 1. Then we need to find the resistivity. So as we know that they are made up of the same material, so rho 1 is to rho 2. Okay, will be equal to how much? Rho is to 2. Because both of them are made by the same material, so which will be equal to how much? Rho and rho cancels. So it's coming equal to 1 is to 1. So this is number 2. So number 2 done. Now after that comes next. Question number 9, 10 and 11 is similar. So let me do question number 10. Question number 10. Question number 10. Question number 10. Now in question number 10 it is given that a wire of resistance 3 ohm. Resistance is given equal to 3 ohm. Okay, resistance is given equal to 3 ohm. Then again the length is given equal to how much? 10 centimeter. 10 centimeter. It is stretched to length 30 centimeter. Okay, it is stretched to how much? 30 centimeter. Okay, new length. Assuming that it was of a uniform area cross section, what will be its new resistance? So in both the cases area cross section is same. Okay, AA. So what we can write is that, and again they are made up of the same material because the same wire is there. So that is why in both the cases rho will be also same. So what I can do here is that as R is equal to 3 ohm, so I can write in place of R rho L upon A is equal to 3. And then what we need to find is that what will be its new resistance. So let us suppose new resistance is R1 which is equal to rho. Okay, length is different, so L1 okay remains uniform. Okay, L1, then again A1 which is equal to, okay. Now next here. Now see, in this case what is happening is that length is increased by 3 times. So L1 is equal to increase by 10 is here, 30 is here. So that means length is increased by 3 times. Okay, so L1, the new length will be 3 times of the previous one. When the length is increased by 3 times, the area of cross section will decrease by 3 times. Okay, will decrease, will become 1/3. Okay, 1/3 of the previous length. So I can write here A1 is equal to how much? 1 by 3 of previous area cross section. So now after this, what we can do is that now R1 is equal to rho. In place of L1, how much I can write? 3L, and in place of A1, how much I can write? 1 by 3A. Now simplify these 3, the numerator will become numerator, so I can write here 3 into 3 rho L upon A, so which is equal to 9. Okay, rho L upon A means it is capital R, so the value of capital R is how much? It is 3 ohm, so 9 3s are 27 ohm is the answer. Okay, so this is how you need to calculate. Okay, let us keep up to this, students. Okay, I think it is understandable. Thank you very much.